Hey everybody. So today we have another touch bar logic board. This is the 820, where's it at? 820-00281 logic board. And the customer sent this in, the whole unit in actually, because it had been liquid damaged and it's no longer powering on. And just a quick glance at this, we can quickly see where the damage is. It's on mainly on this side of the board. I don't think I've seen any on the right side of the board yet. But I'll continue checking it out under the microscope. Looks like it all happened over here in this area. So let me go ahead and show you under the microscope the area that we're dealing with. So we have this little section up here, and then on the back side we have this whole area here, which is pretty extensive. The damage has done here. Like was mentioned, it's no longer powering on. So what we're going to do is pull up the schematics in the board view and see what this area is and possibly what could be causing it to not power on besides the massive corrosion that's going on. So let's go ahead and pull up the board view, which I already have it pulled up here. Let's see if we got a good view. Yeah. So here is this chip, U7650, and all the components around it. So U7650 is the one that is majorly damaged here, and I have it pulled up on the schematics already as well. I'll show you that. So here the U7650, as it mentions here, this is the power to the 5 volt and 3.3 volt supply. This is your power supply for those voltages, which those voltages in this computer are very critical. Those are some major power voltages that are being sent to other components on the board to cause the machine to power on. And without those, you're just not going to get any power to the board. So the issue is you know, we have this corrosion here, so we either need to look into cleaning it and possibly replacing some of these components, and to see if we get power to the board. Before we move on, let me get back over here to the camera view, and I'll show you. I have a USB-C power plug into the board already, and I'm going to plug in my voltage meter, and it's also an amperage meter, and just to see what we're getting to the board. So it's powering on, and as you can see, we're getting 9.8 volts, or 19.8 volts. It's what you're supposed to. It's supposed to be 20 volts, which is 19.8 is what you're most commonly going to get. But look at the amperage there. There's 0.03 amps going to the board, which means the board is not powering on. So just to show you what we're getting on this, and then we'll take a look at it after we repair that area, just to see if we got any change in the amperage. So we'll go ahead and get that started now. Take off that part, and let's look under the microscope again. Alright, and what I'm going to do is I have this Antistatic electronic component cleaner, and I'm going to spray this on this area. This seems to eat up corrosion really well, and it's not going to damage the components on the board. So I'm going to go ahead and spray this on the area and check out what it does here. See, it's foaming up. Let that sit for just a moment. And you can see that color has just been being eaten away. So I'm going to take a toothbrush now to this area. Just gently brush it over and see how much of that corrosion we can get rid of, and if we can figure out what components we need to actually replace. Let's touch it with some microfiber cloth and just dry that area up. So you can see already that it looks 10 times better. But you can see right away as well that this component right here, this cap, has just come off. And looks like we just got some nasty parts on the board. This cap looks kind of junky as well. I'm going to go ahead and replace that. Replace this capacitor. That capacitor just comes off. I'll go ahead and remove these pieces. I'm going to go ahead and replace this power supply as well for the 3.3 volts and 5 volts. We possibly just touch these few things up with some fresh solder. Alright, so I'm going to go ahead and put some flux on the area, and I'm going to remove this power supply chip and remove all the other bad components that I want to take off. Alright, I think that's all we really need to take off. Maybe this one here too. Yeah. Alright, so I'm going to put some of this liquid flux on the board, which I've shown you before. It takes off this corrosion really well, tins your pads nicely, and gets the board nice and clean. So I have a micro pencil on the soldering station right now, so we'll see if this is big enough to do the job. That seems to be. Just going to go along and touch these components up as well. Oh, it came off. Make sure all the solder joints look clean and good. I don't want to leave any corrosion behind, because doing that can just lead to further corrosion. Let me go ahead and change my tip, because this one's not quite powerful enough. Change over back to my regular soldering iron. I mean, this one's good for touching up small components, but the board on this unit is very does a good job at dispersing the heat, taking heat, so very hard to heat it up as much as I need to with a small micro solder tip. Okay, let's see if I can work with this better. Let it heat up all the way. Oh yeah, you can see it's already going much better. Alright. Looks much better. Now what I'm going to do is just pull these parts straight off of a replacement board that I have. Get you in better focus. Alright, here I have a replacement board that I'm going to be pulling the parts off of, just from this area here. And I'm just going to be transferring them straight over. So I'm going to set it like that just so I can see it and transfer it correctly. Alright, here we go. I'm going to first transfer over the power supply chip. And now all these little components around it. Remember, I lost this little component up here while I was cleaning. So go ahead and pull that. It wasn't that one that I lost. Let's see. Look forward. Which one did I lose? I'll tell you what, let's just start. Oh, that's it. This one. This one right here. Okay. Oh, that one's already there. So, alright. So we need to do this one next. Alright, I'll show you the method that I'm using. I don't know if you can, let me see if I can get a better view in the camera for you. Back out just a little bit. So what I'm going to do is I'm locating, so the next one I need is this one here. So I locate it on the board. I grab it first. And then I add the heat gun. Comes off. And then before I start directing the heat on the board, I place it and I add the heat. And I remove the heat, I let go of it, and then I add the heat again. And it floats it back into place. Because if you're trying to do all this and then as you're holding the heat on it, you let go of it, it's going to fly off because the solder is going to be wet and hot. So if you let go of it while the solder is melting, then the component's just going to fly off as well. So it's best to hold it in place, add the heat, watch it flow, remove the heat, let the solder harden, and then let go of it. And then you can aim the heat at it again to make it flow back into place. Just something I've learned over time that makes it a lot easier when you're transferring parts like this to do that, because parts fly off easily. Look how little these are. And also you want to save the heat on your fingers, because your fingers get pretty hot when doing this. Go ahead and add some more solder to this area. That helps things flow better as well, and also keeps the components from flying off. See how that I moved my solder or my tweezers too fast and it kind of flung off. Yeah. This is directly below that. Yeah. The one right beside that one. There. Add some more Flux. Get those parts to flow in place. Okay. Now, what parts do we need? That doesn't have a port there. Okay, I think we're done with the components around the chip. Now we just got to do these bigger capacitors. Take this one. Okay. This cap. Now, with doing these capacitors, you don't want to hold the heat directly, like, right on them, right on top of them, because you can ruin them that way. They will pop if you get them too extremely hot. Let's put more Flux. Capacitor. And the last one. I can't believe we have all of our parts back in place. To believe. Yep. Okay. Alright, so this side of the board should be back to normal. Now remember I said on the other side of the board we have a few components here that are also liquid damage. So spray some of this on there. Use the toothbrush to clean the area. Well, let's go ahead and replace that. It looks like a coil. Might as well. Add some fresh solder to that. And just touch up the pad on this capacitor as well. Okay. Alright, so now let's go ahead and clean it and we will see what we get. So I'll be right back. Alright, so we're back. We got the board cleaned up. Everything's looks to be much better. Let's go ahead and plug in our power adapter and see what we get. See if we get any change in our amperage here. Let's see if I can get this in a way that you can see it. That didn't work. Alright, so here we go. And we have 1.5 amps. So that means our board is powering on. So, and it powers off again, which is normal. We do have to get this back into the machine where there's a battery, so it can recognize the battery as well. But we are getting a board that powers on now, so that's good. And the CPU and the GPU is getting warm, so that's a good indication as well that your machine is powering on. So we'll go ahead and get this back into the machine just to see if we get an image. So I'll be right back about that. Okay, so we have the board back into the machine, got it all installed. Let's go ahead and plug in our power adapter so that we can get it tested out, see what we get. Power to the machine. I heard a little ding that it's charging, and there's an Apple logo. I'm going to cover up the person's name here. So there we go. We now have a working unit. We're going to diagnose this a little further because it was liquid damage, so it's good just to go ahead and check everything over, make sure everything is set and good to go. I'm going to shut this down so I can move my hand. There we go. But that's all that we needed to fix on that. Again, how we found out the problem was just using our eyes, find the corrosion, and just taking the time to clean and replace those components on the board. And we looked at the schematics and board view as well, just so we can have an idea of what area is damaged, why it's not working even though that area is damaged. And anyways, we were able to get it fixed. So that's another one that's a positive at the end. I'm sure the customer will be happy to hear that this is repaired. If you enjoyed this, give us a follow. If you have any questions, please be sure and ask us. And if you're interested in using our service, be sure and visit our website at powerboltminute.com. If you need anything else, just let us know. Hope you have a great day. We'll talk to you later.